Hey guys, we're going to learn the substitution method for solving systems of equations. So this is again when you have two or more equations and you're asked to find that solution, which could either be a point, no solution if it's two parallel lines, or infinite solutions if it's two of the same line. We use substitution to solve algebraically in case we don't have a graph available, or if we graph it and we can't get a solution that's on the corner of the box. So let's take a look at this one. The idea of substitution is to plug one equation into the other and eliminate a variable. So we're going to plug one equation into the other to eliminate a variable. Hope you all enjoyed Mr. Yerkes's Christmas songs in Spanish. I don't know if you can hear it or not, but he's going at it. So, we look at our two equations here, y equals negative 4x plus 8 and y equals x plus 7. Now, in both of them, we have a variable solved for, so we can plug it in for that variable in the other equation. You could have gone either way. You could have put this in for y here. What we're saying is that we know what one of our variables are equal to, so let's plug it in for that variable. And we get x plus 7 equals negative 4x plus 8. I know it seems complicated now, but it'll make more sense in a second. Now, if you notice, we only have one variable, and we can solve this like any old equation like we used to. Subtract 7, x equals negative 4x plus 1, add 4x, add 4x, 5x equals 1, divide by 5, divide by 5, and x equals 1/5. Now notice, x equals 1/5 is a really ugly fraction. And if you try to graph this, you graph these two equations and you got 1/5, you would never know that that was your point. It would just be some estimate because a fraction is very difficult to plot on a graph. Alright, so once we've eliminated that variable, we plug it back in to get the other variable. Plug back in for the other variable. So we have x is 1/5. Let's plug it into this equation. Either of the original equations you can plug back into. Y equals 1/5 plus 7. So y equals 1/5 plus 35/5, which is 7 in that form, where 5 is the denominator. Y equals 36 over 5. So remember, our answers are coordinates. We get 1/5, comma, 36 over 5 as our coordinate. So let me restate our steps. We look for a variable to solve for to get a variable alone. Doesn't matter which variable, you just pick one that's alone. Okay, so in this one, both were set alone, so we could have plugged in either one. We took this equation, plugged in for y, solved for our first variable. Once we got the answer for that first variable, we plugged it back into one of the original equations. Either one works to get our answer. A few quick reminders. Solutions are ordered pairs, always. Coordinates, x, y. You can solve for either variable first. I don't care if you solve for x or solve for y. I'll show you an example here in a second. Always use parentheses when plugging in numbers or equations. We know that from Unit 2, from middle school hopefully. Every time you plug in, you're using parentheses. So let's take a look at this. X plus 3y equals 6, negative 3x minus 2y equals 17. In the last one we had variables solved for, in this one we don't. So we need to solve for a variable. If you look at this, I'd say the easiest one to solve for is x in the first equation, because it's alone and has no coefficient. That's what you want to go to, this one. The one that has no coefficient and is the variable alone. So let's solve for it. X plus 3y equals 6. Subtract 3y from both sides, and all of a sudden you have x alone. x equals negative y plus 6. Now that you know what x is, you can take that and plug it into the other equation. So this is what x is equal to. Let's plug it in for x. I know it might be a little bit confusing, but try and watch this a few times to understand what I'm doing over and over again. And if you see the examples, to build some consistency with them. So negative 3 times negative 3y plus 6 minus 2y equals 17. So all I've done here is I've solved for a variable and substituted it back into the other equation to get one variable only. So I can distribute, and this will be the steps that you use for all of them. 9y minus 18 minus 2y equals 17, so I'm going to solve now. Combine my like terms, 7y minus 18 equals 17. Add 18 to both sides. 7y equals 35. Divide by 7, and y equals 5. So now I have one of my variables solved for. And I can plug that back into either one of my original equations. I'll choose this one and plug it in for y. So y equals 5, let's plug it in. X plus 3 times 5 equals 6. X plus 15 equals 6, subtract 15, and x equals negative 9. So again, my answer is a coordinate, negative 9, comma 5. So what I did is I solved for a variable first, right? Got x alone. Doesn't matter which one you pick, x or y, just the easiest one, like the one that doesn't have any coefficient and the variable's alone. Plugged what I solved for into the other equation for that variable, distributed, combined like terms, added, divided, like we always used to do in Unit 2, plugged back in once I got my answer of y equals 5, and gave you a coordinate. Let's go to one more example. 3y plus 2x equals 4, negative 6x plus y equals negative 7. If I were to solve for this one, I would choose the second equation because y is alone, right? There's no coefficient in front of it. So let's try and get it by itself. Add 6x to both sides, and we should be all set. Y equals 6x minus 7. Right? So now we can use this and plug it in. This is what y is equal to. Just like if y were equal to 3, you plug in 3 for y. But now y is equal to an equation, so you plug it in. You plug in what is on the other side of the equal sign for y. 3 times 6x minus 7 plus 2x equals 4. Distribute and solve. 18x minus 21 plus 2x equals 4. Combine like terms. 20x minus 21 equals 4. 20x equals 25 when you add 21 over. Divide by 20, and x equals 5 over 4. Okay, so again, this is a type of situation where when we solve it out, we get a number that we couldn't kind of figure out if we picked it off a graph. Again, I solved for my variable y, plugged back in for y, distributed once I plugged in, right? So now I only have one variable, only x's. And I solved all the way out, and now I plug it back in. So I can plug it back into the second one or the first one, either one. So I'll say negative 6 times 5 over 4 plus y equals negative 7. Negative 6 times 5 over 4 is negative 30 over 4, or 15 over 2. Just use your calculator for any multiplications like this. So negative 15 over 2 plus y equals negative 7. Add 15 over 2. Add 15 over 2. Y equals what ends up being 1/2. So you make a coordinate from your x and y, 5/4, 1/2. Okay, and that's it. So this is how you do any type of substitution problem. You pick the easiest variable to solve for in the beginning, whether it be x in this one or y in this one, whatever it wants to be, whatever the problem gives you, you solve for that variable, substitute that answer in, and then from there you combine like terms, move the numbers over and divide by the coefficient, get an answer, plug the answer back into either one of these two, and solve. Sometimes, if you're lucky, like in the first one, you'll be given the variable already solved for. Come in ready to discuss this, ask questions, and apply it.